Let's look at finding the determinant of different orders. So the very first thing is we have order 1. So I'm taking a matrix which is equal to M. The element is M. The determinant over here will be just M. As simple as that. For example, if I have say D which is made up of 2 or maybe minus 4.6, then the determinant is a negative and a decimal in this case. So we need to understand that yes, we can find the determinant which is negative as well. It's not magnitude. Yes, a negative. Don't get confused with magnitude and this. Now case 2. So things are going to get a bit harder. Actually this 2 is easy. The one which is difficult is order 3. I have an animation for you guys to help us with this. Make your observation. I'll play it again. So this is of order 2, the square matrix. So first thing is we are picking which two elements? The diagonal ones, left to right, top to bottom. So those two what are we doing? We are multiplying. Next, we have a negative sign, and then we are taking the product of the other two elements from the other diagonal. So that would be your procedure. So let me give an explanation over here. We have this is 2 by 2 matrix, right? So the very first thing that we need to do is pick up these two elements. So the modulus of A is A into N. Next, we need to find the modulus, not the modulus, sorry, product of the other two variables along the other diagonal and take a difference between them. Right? So this is your answer. If you look at it, if I take this as A1, this is B1, A2, B2, this formula will turn out to be A1 into B2 minus A2 into B1. This is what we saw in triangles as well, right? Not triangle, sorry, what am I telling? Linear equation. That's your determinant D. Okay, we have studied it before, right? The same thing over here as well. We had the same word and D and all of that, if you guys remember. Okay, so let's look into this with an actual example, actual values. Right? It's as simple as that. So let me pick another example with the negative and all of that. So minus 4, 3, 1 and 6. What should I do first? B is equal to, this 2 should be the first to be picked up. Always remember. So it is minus 4 into 6 and the product of other two and a negative in between them. And when we solve this, it will turn out to be 24, 27, negative 27. Right? Now the difficult one. This will take some time. So I want you guys to listen to everything carefully and learn everything. Every bit is important. So determinant of matrix of order 3 or more, to be honest, can be determined by expressing it in terms of second order determinant. So what we saw was second order determinant. That is, we will break it down to second order determinant. Okay, so basically something to do with 2 by 2. So something to do with 2 by 2. Now, this is known as expansion of a determinant along a row. This can be done with a column also. since there are 3 rows and 3 columns, right? Let me do this. So in general, we have a determinant, say B, sorry, not determinant, matrix B made up of A, B, C, say M, N, E, and B, U, T. So this is 3 by 3 clearly. Now we have 1, 2, 3. 1, 2, 3. So there are 3 plus 3, 6 possibilities. What does that exactly mean? Let me show this. This is a procedure. Don't overthink it. Okay. So this is a procedure. You just have to have a look. Just a second. This is not the one to be played first. So this is the right one. So we'll be looking at expanding along the first row. Make your observation. I'll explain it. Remember, this is a procedure. Learn the procedure. Now, what did we see? We have picked the first row. That is, there are 3 elements from the first row. For each of this, we are multiplying with 1, minus 1 and 1. It depends on something that I'll explain. Along with that, we are multiplying with matrix. Actually, it should be determinant of the matrix. So I should have changed the sign, but anyways, it's so. So as and when we are going through each of these elements, we have 2 by 2 matrix throughout. And this 2 by 2 matrix are picked up from the ones which are not part of the row and column which the A13 or A12 or A11 comes from. Again, I repeat, 1, minus 1 and 1. It has a particular rule that I'll talk about it later. Then A11, A12, A13 are the elements of the first row. Then we are multiplying each of this with a particular 2 by 2 ordered matrix. We have to find the magnitude, actually not magnitude, determinant of each of this. So where did this element comes from? That is important. This element comes from the non rows and columns which the A11 comes from, for example. So the row and column which the elements which are not part of it is over here with the green ones. Same thing over here. The green ones are not part of A12. The rows and the columns basically. And for A13, this set of elements are not part of it, right? Okay, so one last time, just have a look. The same rule has to be followed with all the rows and columns wherever we do. I'll be showing all of those variations as well. Let me put it on the paper. Now we'll make use of this itself. So first thing is we're going with the first row. Okay, so we're looking at the first row scenario. So that's our first row. It has A, B, C as its elements. Now first we have to pick up A. A has this as its column and that as its row, right? So we'll start off with the determinant of B is equal to 1 minus 1 to the power of 1 plus 1. How did it come? I'll explain. Into A itself, into the determinant of the elements which are not part of its row and column. So in this case, basically it would be N, E, U and T. Right? So that's your first element. Okay, that's your first part of the answer. Now, next I'll pick up B. So B is coming from first row and second column. So all I have to do over here is minus 1 to the power of 1 plus 2 into B into the determinant of the elements which are not part of your first row and second column, that is M, E, V and T. And finally we have plus of minus 1 whole to the power of 1 plus 3 into what should it be? Yes, C. So let me pick up C. So C is coming from last column and first row. So we have to multiply C and the magnitude of M, N, V and U. Right? Okay, so I hope that is clear. So let's discuss where this 1 plus 1, 1 plus 2 and 1 plus 3 comes from. This is basically where the element is present in matrix. A is present in first row, first column. First row, first column. Then B is present in first row, second column. This is nothing but your position of A. Position of A. Similarly, this is position of B. Okay, so this comes from position of B. And this is position of C. So I can write it in general. I can get B from, let me leave some space, summation of minus 1 to the power of I plus j, and this is Aij, and we need to create a new matrix which is of order 2 by 2, and this is nothing but your position of Aij. That's where this entire thing comes from, and this is your elements from non ith row and jth column. Okay, so this is your entire set of rules. Again, just understand the rule and you're done. So let me explain with an example. So we have 3 by 3 matrix. Expansion along the first row is what we're looking at. And finally, on solving this, we'll get minus 12. Right, guys? Let me show along the row 2. Okay, you'll understand the minus 1 to the power of aspect. So we are picking up second row. A21 has a power of 3. 2 plus 1 is 3. A22 is 4. 823 is again 5. So E odd, even odd. Odd power will give us minus 1, plus 1, minus 1. So what does it mean? Just observe. So we're ignoring the row and column, elements from the row and column, and everything else is a new matrix. We can see the first answer is negative. while the second one will be positive. Minus 1 to the power of even is 1, right? And next one is minus 1 to the power of odd. Okay, I hope that makes it very clear. So this is expansion along the second row, right? And now let's look at a column. Expansion along the first column. So that's your first element. So what should be the power? Think of it, 1 plus 1. It's an even power, correct, right? And so it will be minus 1 to the power of n is plus 1. Then a1 1 into the magnitude of, not magnitude, determinant of, yes, a22, a23, a32 and a33. Imagine that. Is that correct? This is what you guys thought of? I hope so. Then where should we go? What is the next set? First column. Remember, it's first column. Yes, we have to move to along the column A21. Right? So A21, ignoring the elements from its row and column, everything else we picked up, made the new 2 by 2 matrix. And here the power is negative because 2 1 has a power of, or a position of odd, right? It's a position of odd, in a sense 2 plus 1, right? So it's a position of odd, so we have negative. And finally, yes, A31. 3 plus 1 is 4, so it's a power of even. So it will become, minus 1 will become 1 and A31. So this is your expansion of matrix, which is of order 3 by 3. And this would be your way of going across. So I'll do one quick example. Let me pick up an easy set of numbers. 0 or maybe minus 2, 0 and minus 3. Okay, then let this be easy numbers as well. 1, then 3, then 0 here, 6, maybe not 6, minus 2, minus 1 and 2. Okay, not 2, maybe 4. Yeah, so I'll go with first row, right? So B, and then I'm using expansion along the first row. So I will be picking up minus 1 to the power of 1 plus 1. That's where 2 comes from. And I should ignore this set of things, and we have 3, 0, minus 1 and 4. Next would be, since I'm using expansion along first row, R1 basically. Next we have minus 1 to the power of 1 plus 2 into 0 into anything is 0 itself, so I don't need to bother. Minus 1 to the power of 1 plus 3. This is minus 3 into magnitude of 1, 3, minus 2 and minus 1. Is that correct? So ignoring the first row and the last column. And finally we have this to be 1 into 2 into this would be 3, 4 3s are 12 plus actually minus 0. It doesn't matter anyways. Next would be minus 1 times of 0. So I'm just writing it. And finally, we have plus of 1 into minus 3 into this would be 1 into minus 1 is minus 1 minus of minus 2 into 3 minus 6. Okay, further simplification 24. Then this is 0, ignoring that. Or let me write it since it's first example. And this is plus 6 minus 5, it is 5. So this is 15 and the overall answer is 9. So this is how you do it. Okay, you do it yourself, only then you will get it. If not, it's not going to be easy. Yeah, so order 2 is something that you guys have to be very clear with. It's very simple. Order 3 is a bit complicated and there are many variations. So why is that variation, when to use what, we'll be talking about it, and we'll be using it throughout the course, so throughout this chapter, so you'll get familiar with it in time.